Welcome back to our channel Concept with Clarity 1. In this lecture we will try to discuss about a 3 variable K-map. Okay, so what is a 3 variable K-map? If the number of inputs are 3, then to minimize that Boolean function we will be using a 3 variable K-map. 3 variable K-map means 8 cells and it looks like this. Okay, so total number of cells are 8. So this is X, Y, Z. Okay, this is X bar X, and this will be Y bar Z, YZ, and YZ bar. Okay, so see here in this 3 variable K-map, the ordering, okay, the ordering of the numbers will be like this, in this fashion, in the code sequence. You see here 0 is kept here, 1 and 2 is kept here. Okay, and 3, 4, 5, 6 and 7. Okay, so what is this is nothing but gray code sequencing. Okay, so actually if you see 1 is represented by 0, 0, 1 and 3 is represented by 0, 1, 1. See, at any point of time, okay, there will be only 1 bit difference. Okay, only 1 0 is changing to 1. Okay, similarly 3 to 2, if you see 3 is 0, 1, 1, 2 is 0, 1, 0. Here also you see only 1 bit difference. Okay, only 1 bit is changing, right? So in this sequence we'll be taking the 3 variable K-map. Okay, so now directly we shall go into solving a problem. Let us take if f is equals to sigma m of, what is this? Sigma m is nothing but sum of the products form. Okay, sigma m of, let us take 0, 1, 3, 5, 6. Okay, 0, 1, 3, 5, 6. Okay, minimize by using a K-map. Okay, first of all we should know how to what are the number of inputs to take the particular K-map. Okay, the highest number is 6. Okay, 6 is like it is denoted by 110, right? So it is a 3 variable. 110 means 3 variable. Okay, 0 to 7 numbers are in 3 variable range. Okay, so now we will try to plot the same thing in this one. Okay, and for a 3 variable K-map, for a 3 variable, first let me plot, then I will tell you. Okay, for a 3 variable K-map I will draw this one. 1, 2, 3, 4. This is X, Y, Z. Okay, X, Y, Z, X bar X, Y bar Z bar, Y bar Z, YZ and YZ bar. Like I told you, we'll be taking the gray code sequence 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so now let us plot the ones into this. Okay, at 0, 1, 3, 5 and 6. Okay, for our convenience I shall be taking a 7 also into this. Okay, 7 also into this, right? So now in a 3 variable K-map, okay, possible mappings are, first one is quad and second one is pair. So first preference should be for quad. Quad means 4 ones adjacent, side to side, 4 ones adjacent to each other. If 4 ones are adjacent to each other, then that is a quad mapping. Then second one is pair, 2 ones adjacent to each other. Okay, if 2 ones are adjacent to each other, then that's a pair mapping. Okay, so you can see here, so what is there, like there are 4 ones here. This is quad number 1. First preference should be for quad, then only you check for pair. Okay, so this is one quad and second one, this is one pair. So this is 2 and this is 3. Okay, now let me write the answer. Okay, for quad 1, like yesterday I told you in the last class. So you write your variables here, X, Y, Z. Okay, and you write the possible, the corresponding values here. Okay, so first of all for quad, this is the one, right? This one is X bar, Y bar, Z. this one is x bar, y bar, z. You write this one. And for this one, okay, so this is x bar, y, z, x bar, y, z. And for this one, this is x means 1, y bar, z, and for this one, this is x, y, z. Okay, so what we told, if there are zeros and ones are repeating, then you simply cross that one. Okay, only all ones are there for z, therefore for quad 1 it is z. Similarly for pair 2. Okay, for pair 2, what is my pair 2? This is my pair 2, right? This is my pair 2. So again you write here x, you write here x, y, z. Okay, x, y, z, right? So x bar, y bar, z bar, x bar, y bar, z bar, and x bar, y bar, z, x bar, y bar, z. Okay, so what is the answer here? X bar, y bar, right? Next, the third one for pair 3. So again you write x, y, z. Okay, so you can see here, what is this? X, y, z, x, y, z, and this one is 6, that is x, y, z bar, x, y, z bar. Okay, so this is x, y is the answer. Therefore f is equals to 1 plus 2 plus 3, that is equals to 1 was only z plus x bar, y bar plus x, y is the answer. Okay, so you can see here, so number of inputs are 3, number of outputs is 1, hence my answer is xz plus x bar, y bar plus xy. Okay, similarly I can take another example. F is equals to sigma m of you see here, let me show you 0, 2, 4, 6, 0, 2, 3, 4, 6. Okay, 0, 2, 3, 4, 6. Okay, we will try to minimize the same thing by using a K-map. Here also number of inputs are equal to 3, number of outputs equal to 1, that is f, right? So you can take this as a K-map like this. This is x, y, z. Okay, now you see here, this is 0, 1, 2, 3, 4, 5, 6, 7. This is important. First step is you complete your K-map, then only it will be easier for us to find out the answer from it, derive the answer from it. Okay, so 0, 2, 4, 3, 4, 6. Okay, now you see here also I have a quad mapping. First of all, let us look for a quad mapping. So this is also a quad mapping. This is a quad mapping. How it is a quad mapping is, whenever we fold that particular K-map, if the cells are touching to each other, then also 4 corners, that is also a quad mapping. Okay, and this is first preference is given to quad, this is 1, and the second one is this is a pair, okay, so this is 2. Therefore my f is equals to, I can also directly see and tell the answer. Okay, you can go with this method for finding out the answer, or directly you can tell the answer like this. Okay, in this 4, okay, this is a quad, right? In this 4 cells, you try to look which one is common. Okay, you see here x bar and x is varying, so there is no x term here. Here y bar, z bar, in this 4 cells, you see this is y bar, z bar, this is y, z bar. Y is also varying, only z bar is common, plus, and in these 2 cells you see here x bar is common, and in these two cells y is common. Okay, x bar y. Therefore, my answer is equals to z bar plus x bar y. Okay, now let us take an example like this. Design an 3 input circuit, 3 input digital circuit which produces an output whenever there are odd number of ones in the input, Okay, now see here instead of giving a question directly, there is a statement. Okay, so what we need to do, we need to design a 3 input circuit, okay, which produces an output whenever there are odd number of ones in the input. Okay, so we will try to derive this one. How to derive? You see here 3 inputs, let us say x, y, z, and output f. Okay, so you see here 3 inputs means combinations are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. Okay, now what was this statement? The statement is we need to, which produces an output whenever there are odd number of ones. So if there are odd number of ones in the input, then my output will be equal to 1. Okay, that is the statement, right? Now you see here how the output, there are odd, no ones. Okay, here odd number of ones, so my output will be 1. Here also odd number of ones, my output will be equal to 1. So here it is 0, here it will be equal to 1, 0, 0, and 1. Correct? So if there are odd number of ones, then my output is equal to 1. Right? Now we will try to draw the K-map for this particular design. Okay, you see here. So what is this? I will draw the K-map, 3 variable K-map, because my number of inputs are 3. Okay, you see here, whenever we are trying to, here we are trying to get the output with respect to truth table. Okay, my truth table sequence is x, y, z, right? X, y, z. So you write your K-map also in the x, y, z sequence only. Okay, you write it in the truth table sequence only. Okay, then only you will get the answer, correct answer, right? X, y, z. Okay, you should not take y here, x and z there, right? So whatever there is in the truth table, that only you should take. So this will be x bar x, and this will be y bar z bar, y bar z, y z, and y z bar, right? So 0, 1, 2, 3, 4, 5, 6, 7. So this is 0, 1, 2, 3, 4, 5, 6, and 7. Right? Now you see here where I have a 1. Okay, at 1, 2, and 4 and 7. 4 and 7. Okay. Now if you see, you don't have a quad mapping, no quad mapping, no quad, or no pair. Okay, then what you have to do is, whenever there is a 1 left like this, whenever there is a 1, like everything is left like this, what you do is you simply circle it. Okay, you simply circle it. Okay, and you write the answer, whatever the combination is there, that directly. Okay, therefore f is equals to, you write the sequence, this is x bar y bar z plus x bar y z bar plus x y bar z bar plus x y z. Okay, so there is no minimization in this, right? But what we can do is simply I can turn this equation into, like this is simply nothing but ax or bx or c. Let us see, can I derive this one also. Okay, I can, instead of minimizing, I can write this equation like this: y bar z bar plus yz. Okay, so this is x bar into y exclusive or z plus x into y exclusive nor into z, y exclusive nor z. Okay, so if I take this y XOR z as a or something, okay, this is simply let y XOR z is equals to a, that is equals to x bar into a plus x into a bar. This is nothing but x XOR a. So that is equals to x XOR y XOR z. Therefore, f is equals to x XOR y XOR z. Now, if I wanted to design, it is nothing but it's a simple 3 input XOR gate x, y, z, and this is f is equals to x XOR y XOR z. Okay, so this is the design. Okay, so I hope you have understood all the concept in this. So for a 3 variable K map, the possible mappings are a quad and a pair. First preference should be given to a quad, then only preference should be given to a pair. Okay, I hope you have understood the concept for a 3 variable K map. Now if you have understood the concept, please like the video, share and subscribe to the channel. Thank you for watching.